Welcome back. This is 10.1 part 2. And here's a little bit more complicated example because it's, the word problem. We've got to just sort things out. Page 496, number 18. A computer system administrator notices that computers running a particular operating system seem to crash more often as the installation of the operating system ages. She measures the time in minutes, no less, before crashing for 7 computers 1 month after installation, and for 9 computers 7 months after installation. So you can see 1, 2, 3, 4, 5, 6, 7 pieces of data for the 1 month group, and 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data for the 7 month group. So you can have different sample sizes. And I do comment here, we have small samples, so we should be told that we have samples from normal populations. We did skip 7.6 that gives tools to assess normality just by looking at a sample. So we're going to skip parts A and B of this problem. And notice in the homework, I do often invite you to skip certain parts of questions that ask you these kinds of things. We're just going to do part C, and I'll just tell you that this already works out. So it says construct a 95% confidence interval for the mean difference in time to crash between the first month after installation and the 7th. So I see that word mean in there. Could have said average or something. And because we're working from data, what I need to do right away is get this first sample set, these first 7 numbers. Those are going to go into your calculator in L1. And the 9 numbers from the second sample, those are going to go into L2. So maybe take a moment and do that. I'm going to do it too. And a couple of things that jumped out at me as I put these numbers in my calculator. The first set of numbers are all over 200 minutes. And remember, 60 minutes in an hour, so 180 minutes is already 3 hours. So these times here are up like in the over 3 hours into 4 hours kind of a thing. And in the second group, I see that one number 59, there's a computer that crashed in the first hour. And 85 minutes is not even an hour and a half kind of a thing. So it certainly looks like the second group of numbers. After the computer's gotten a little older, they do look like they're less. But here we go. So we put the data into L1 and L2, and we're going to run 2samp t int. Make sure again it's the interval, not the test. And you want to choose the data option this time. And for sure, list 1, assuming you did what I did, that should say L1. And list 2 should say L2. And then we didn't do anything with frequencies. So the frequency for the first list should just be the number 1, no list there. And the frequency for the second group should also just be a 1 because there's no lists there. And then of course the confidence level is our 95%, either whole number 95 apparently, or the 0.95. And then that pooled question, once again, no indication here of any standard deviations, so we'll say no there. And it does in fact take a moment to calculate. Once you press calculate, I have to wait a few seconds. And then I get my interval, 39.434 up to 128.41. So it is true that we're 95% confidence that the mean difference is between these two numbers. And we could write all that. We think that the mu1 minus mu2 is in here. But I think, again, more interesting and more useful to us is let's put that consideration onto the number line. And our interval is once again entirely on the positive side of 0. So 0 over here somewhere to the left. So more importantly is, I'm going to introduce some new language. We think there is a significant difference between the two times. So let me say this a little bit differently than my previous example, because 0 is not in the interval. There is a significant difference. I'll write it out, between the crash times. So reading it all again, because 0 is not in the interval, there is a significant difference between the crash times after 1 month and after 7 months. And in fact, we can be more specific because mu1 minus mu2 is positive, then mu1 is greater than mu2. The crash times after 1 month, the times were longer and they got shorter. So after 7 months, the crash times are shorter. The machines are, in fact, crashing more quickly. So that is where these interpretations are going to become more useful. Is there a difference, first of all, a significant difference? And that will always be yes when 0 is not in the interval. And then we can decide sort of which number might be larger and which number is smaller if there is a significant difference. Okay, I think we have time to go on to another example. Page 497, number 24. Are low-fat diets or low-carb diets more effective for weight loss? So we have a sample of 77 subjects that went on a low-carb diet for 6 months. At the end of that time, the sample mean weight loss was 4.7 kilograms with a sample standard deviation of 7.2 kilograms. And then a second sample of 79 subjects went on a low-fat diet. Their sample mean weight loss was 2.6 kilos with a standard deviation of 5.9 kilograms. So we want to construct a 98% confidence interval for the difference in the mean weight loss between the low-fat and low-carb diets. So I'm going to go ahead and take those samples in order. As long as you label correctly, and you can set up your samples, not correctly, but label clearly, you can set your samples up in either order. And if you happen to choose the opposite way from the book, you'll get all the correct conclusions, except you might conclude the opposite. Like you might subtract and get a positive number, whereas the book might end up with a negative number because they subtracted in the other order. So don't panic if you think that you did everything correctly, but something just seems opposite from the book. Ask about it. That would be a great thing to put on the discussion board or ask about it during class time. But I will take the things in order. So I'm going to go ahead and write down the low carb first, because that's what was given to us first in the problem, even though it sort of mentions it the opposite way in the problem itself. But anyway, the low carb, we have a sample size, that would be an N, and then we have the sample mean for that group, X1 bar, is 4.7 kilograms, and the sample standard deviation is 7.2 kilograms. Then we have our second sample, which is the low fat group, and we have a second sample size, 79. We have a second sample mean of 2.6 kilograms. That seems noticeably less. And then a sample standard deviation of the second group, 5.9 kilograms. Okay. So right away, again, we don't have to do this, but I might ask about this. If we wanted to find the point estimate, we would subtract these two means, x bar 1 minus x bar 2, and get 2.1 kilograms. So is that significant? It's certainly not 0. It's not, we're not thinking that they're equal, but is that a significant difference? That's what we're going to try to find out with our interval. So 98% confidence interval, we're going to do 2 SAMP t-test and go back to the stat option. And I won't write it all out again because I've just written it up there. And I get eek. And did you catch my mistake there? Right, we're doing intervals in this section. So I need to do 2 SAMP t interval. And I went to the stat option, make sure it's the 98% confidence level. And I got this interval here, negative 0.3823.4 up to 4.5823. So before we go to part part B, let's just sort of think about what we've just found. If we put this on a number line, Our point estimate is right in the middle of what we just found. 2.1 is the middle of our interval. And then this interval goes all the way up to 4.6, let's say, and then down to, ooh, negative, that's a hard one, negative 0.4 thereabouts. So notice how this has a negative number on the left and a positive number. So if I wanted to put 0 in this diagram, it's pretty far over there, but there's our 0. It's inside the interval. So in fact, there's no significant difference. So since 0 is in the interval, there is not a significant difference. And I think I've actually just answered B now. So a dietitian claims that both diets are equally effective. Does the interval contradict this claim? And so again, we found in part A that there is not a significant difference. So I'm going to kind of repeat that. So as I say here, since 0 is in the interval, it is possible that mu1 minus 2 equals that very 0, which in turn means that mu1 equals mu2. So to directly answer the question, the interval does not contradict the claim that the diets are equally effective. They may or may not be. We just don't know based on this interval. And that wraps up, yep, it does, 10.1.